Hello grade 5, welcome back to our video tutorial lesson. I am your Sir Collin, your tutor in Math 5. And of course, for this week, our topic is about finding GCF and LCM, which is in module number 6, week number 3 of your first quarter. Before we start our lesson for this week, I want you first to know the following. First, what do we mean by prime number? Second, what do we mean by composite number? Well, first, prime numbers are numbers which are greater than 1 and has only 2 factors. I would like to put emphasis that prime numbers are numbers which has only 2 factors, and those factors are 1 and itself. How about composite numbers? Composite numbers actually are also whole numbers greater than 1, but it has more than 2 factors. Remember, if the factor is more than 2, then that number is a composite number. So, I just gave you the meaning of a prime number and a composite number, which are very important in our discussion for this week. Get ready. So now, let us identify if what are the prime numbers and composite numbers from 1 up to 10. But before we could identify if a number is a prime or composite, we need to know first what are the factors of the following numbers. When we say factors, these are the numbers we are multiplying. Now, what are the numbers that we need to multiply to give a product of 1? And of course, that's only 1. 1 times 1 is equal to 1. How about for 2? Of course, that's 1 and 2. Because if you will multiply 1 and 2, it will give a product of 2. For 3, the factors of 3 are 1 and 3. For 4, we could multiply 1 times 4, and of course, 2 times 2. Because 2 is being repeated, we could just only list down one number 2. And for 5, that's 1 and 5. For 6, that's 1 times 6 and 2 times 3. For 7, the factors of 7 are 1 and 7. For 8, we have 1 times 8 and 2 times 4. For 9, that is 1 times 9, and of course that's 3 times 3. Because 3 is repeated once again, we will just list down one number 3. And of course, for 10, we have 1 times 10, 2 times 5. Those are the pair of factors which we need to combine or to multiply in order to give the following numbers. And of course, you will have to list down all those factors, and this will sum up the factors of a number. So number 1 here has only 1 factor. Number 2 here has 2 factors. Number 3 has 2 factors. Number 4 has 3 factors. Number 5 has 2 factors. Number 6, 4 factors. Number 7, 2 factors. Number 8, 4 factors. Number 9, 3 factors. And number 10, 4 factors. So this time, it would be easier for us to tell if a number is prime or composite. Remember that prime number has only 2 factors, and composite number has more than 2 factors. So number 2 now, we could say this is a prime number. Number 3 is also another prime number. And another prime number here is 5. Another prime number is 7. Now, the rest of the numbers, if you notice here, number 4, more than 2 factors, so this is now a composite number. Number 6, likewise, has 4 factors, so that's a composite number. Number 8 is a composite number. Number 9 has 3 factors, another composite number. And number 10 has 4 factors, so another composite number, because this number has more than 2 factors. How about number 1 this time? Of course, number 1 is neither prime nor composite because it doesn't have 2 factors or more than 2 factors. So we could not classify that number 1 as prime or composite. That's why number 1 is a special number. This time, let us know what are the prime numbers less than 100. Here are the list of the prime numbers from 1 to 100. You might be wondering, why do we still need to study prime numbers? Of course, prime numbers are very important in order for us to answer problems about GCF and LCM. Now, out of these prime numbers, we can get the prime factorization of every number. Let us always take note that 1 is a factor of every number. Prime factorization is one of the methods in getting the GCF and LCM of 2 or more numbers. So this time, let us first review on how to get the prime factorization of every number. So let us start with 120. What's the prime factorization of 120? To get the prime factorization of 120, we also have different methods in order to arrive for its prime factorization. The first one is through factor 3. So all we have to do is factor out 120 to 12 and 10, or to any factor as you wish, as long as the product is 120. This time, ask yourself if 12 is already a prime number. No, it's not. So we could still split it or factor it out to 4 times 3. Also, we have to factor out 10 as to 2 times 5. Now, check if the factors are already prime or not yet. So 4 is not yet a prime, so later we could still factor it out. 3 is already a prime, 2 is already a prime, and 5 is already a prime. So, therefore, the last thing that we have to do is to factor out 4 again. So 2 times 2. Well, 2 is a prime and 2 is a prime. Therefore, the prime factorization of 120 is 2 times another 2 times another 2 times 3 times 5. If possible, you arrange your numbers or your factors from smallest to biggest. So the prime factorization of 120 is 2 times 2 times 2 times 3 times 5. Another method that we could use in getting the prime factorization of 120 or any number is by the use of continuous division. And how to do the continuous division? Simply divide 120 or the number by any of the prime numbers. So, for example, 120 is obviously divisible by 2. So, 120 divided by this prime number is equal to 60. Still, 60 could be divided equally by 2, which is a prime number. So, that is equal to 30. Now, 30 could still be divided by 2, so the answer is 15. 15 this time is divisible by 3, so the answer is 5. And 5 could be divided by 5, which is a prime number, so the answer is 1. If you already reach 1, simply, here's your prime factorization. So the prime factorization of 120 is 2 times 2 times 2 times 3 times 5. Both methods yield the same answer. So it simply means that the prime factorization of 120 is 2 times 2 times 2 times 3 times 5. So this time, I think you are now ready for our first activity. Our first activity is to get the prime factorization of these numbers. That is also reflected on page number 3 of your module. However, if you don't have the module with you, you can pause this video and try to get the prime factorization of all these numbers from 1 up to 10. Good luck! This time, let's answer some of the items in your activity. For item number 1, which is 128, to get its prime factorization, obviously, 128 is divisible by 4. So we could factor it out to 4 times 32. The next thing that we have to do is check if the factors are already prime or not yet. 4 is not yet a prime, so this could still be factored out to 2 times 2. Then 32 could be factored out to 8 times 3. Now, 2 here is a prime number, and 2 here is also a prime number. However, 8 is not a prime number, and 3 is a prime number. So this time, we could still factor out 8 to 2 times 4. 4 is already a prime number. 2 is already a prime number. However, 4 here could still be split or factored out to 2 times 2. That gives us the prime factorization of 128 as 2 times 2 times another 2 times another 2 times another 2 times 3. So that's 2 times 2 times 2 times 2 times 2 times 3. That's how to get the prime factorization of 128. Let's try to get the prime factorization of 2200. 2200 could be divided by 22 times 100. Obviously, 22 times 100. Now, 22 is not yet a prime, so we could still factor it out to 2 times 11. And 100 at the same time is not yet a prime, so that could be factored out to 2 times 50. 2 here is already a prime, 11 is a prime, 2 here is a prime. 50 could still be factored out to 5 times 10, obviously. So 5 is a prime, 10 could still be factored out to 2 times 5. 2 is a prime, 5 is a prime. So that completes our prime factorization for 2200, which is equal to 2 times 2 times 2 times 5 times 11. Again, the prime factorization of 2200, 2 times 2 times 2 times 5 times 11. Now, let us use our skills in prime factorization in getting the GCF and the LCM of 2 or more numbers. Let's try to look at the problem here. Mary and her friends were assigned to decorate their classroom. There are 3 pieces of ribbons measuring 16 centimeters, 24 centimeters, and 40 centimeters respectively. Mary wants to cut them into strips of the same length. What is the largest possible length of each strip? In solving problems, we always have to remember the steps I've shared to you in my previous episode or previous video lesson, which is the Polias 4 steps in solving the problem. First, we need to know first what is asked. What is asked here is the length or the largest possible length of each strip. If they are cut into the same length, the given that we have here are 16 centimeters, 24 centimeters, and 40 centimeters. Of course, what shall we do, or let us plan this time if what's the best solution for this problem? Obviously, this problem is about GCF. Why GCF? We are only asked if to what number we could divide 16, we could divide 24, and we could divide 40 evenly without remainder. By doing that, so we will have to get the factors of 16, 24, and 40. Therefore, if we are getting the factor, so we are looking for the greatest common factor because of the word largest. We are looking for the longest length of ribbon that we could cut from each measure in order that we will have an even size of all the ribbons. So, to get the GCF of 16, 24, and 40, we could utilize the prime factorization of 16, 24, and 40. After that one, we will get their common. Then, after that one, we will look for the greatest possible factor of 16, 24, and 40. To solve for the greatest common factor of 16, 24, and 40, all we have to do is to get the prime factorization of 16. 16 is equal to 2 times 8. 2 is a prime. 8 is 2 times 4. 2 is a prime. 4 is equal to 2 times 2. So the prime factorization of 16 is 2 times 2 times 2 times 2. However, for 24, we could factor out 24 as 6 times 4. 6 is not yet a prime, so 3 times 2. And 4 is not yet a prime, so 2 times 2. Prime, 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 prime. 2 times 2 times 2 times 3. That's the prime factorization of 24. This time, let's try 40. 40 can be factored out to 4 times 10, and 4 can be factored out to 2 times 2, prime and prime. However, 10 can be factored out to 2 times 5, prime and prime. Therefore, the prime factorization of 40 is 2 times 2 times 2 times 5. After getting their prime factorization, the next thing that we have to do is look for the common factor, CF or common factor. They are common with 2. They are common with another 2. They are common with another 2. So their common factors are 2 times 2 times 2, or that is equal to 8. 2 times 2 is 4 times 2 is 8. So therefore, their greatest common factor, or GCF, is 8. It simply means that this 16 is divisible by 8, which is equal to 2. This 24 is also divisible by 8, which is equal to 3. And this 40 is also divisible by 8, which is equal to 5. Therefore, all this length, 16, 24, and 40, are divisible by 8. Therefore, the greatest common factor of 16, 24, and 40 is 8. Therefore, we could divide, or we could cut the length of ribbon, which is 16, 24, and 40 by 8. That's the largest length that we could get. Now, we could also divide, or we could also cut 16 by 2, 24 by 2, and 40 by 2. We could also cut 16 by 4, 24 by 4, and 40 by 4. However, the greatest factor that where we could divide 16, 24, and 40 is 8. Therefore, the answer for this problem is 8 centimeters. We could also check our answer by another method. And this method is what we call continuous division. Continuous division in getting the GCF. Of course, we have to look for the GCF of 16, 24, and 40. So, try to think of a number which could divide 16, 24, and 40. Obviously, all numbers are even, so they are divisible by 2. 16 divided by 2 is 8. 24 divided by 2 is 12. 40 divided by 2 is 20. Now, all these three numbers again could still be divided by 2. So the answer is 4. The answer is 3. Oh, sorry. The answer is 6, I mean. And the answer here is 10. Still, 4, 6, and 10 could be divided by 2. The answer is 2. That's 3. And that's 5. Is there still a number that could divide 2, 3, and 5? Or any prime number that could divide 2, 3, and 5? If there's none, therefore, here's the GCF of this number 16, 24, and 40. 2 times 2 times 2. Again, 2 times 2 times 2, which is also equal to 8. Therefore, the answer is still 8 centimeters. Continuing on, let's now try to look at problem number 2 on page number 4 of your module number 6. And here's the problem. Grand Tours van Route A arrives at its stop every 8 minutes, and van Route B arrive at its stop across the terminal every 16 minutes, and the van Route C arrives at the gas station stop every 24 minutes. If all the 3 vans are currently arriving at their stops, how many hours will pass before all the 3 vans arrive at the same time? To solve this problem, we still have to follow the steps of Polya. First, we need to identify what is asked in the problem. The second thing that we have to consider is what are the given in order for us to solve this problem. So, we are asked here if how many hours will pass. Considering that we have here the given of 8 minutes, 16 minutes, and 24 minutes, you are asked if how many more minutes or how long will it take in order that these 3 will stop together. So to solve this problem, we have to think that factors will not work here because the greatest factor of every number is the number itself. However, in this case, how many more hours will pass? So it should be over and more than or beyond the 24 hours. So we have to look, instead of looking for the factors, we will look for the least common multiple or the multiple of 8, 16, and 24, wherein all these 3 will meet together. So, to solve this problem, look for the LCM, or first the multiples of 8, 16, and 24. Look for their common, then after that one, look for the shortest time or the smallest time wherein these 3 numbers will meet together. So now, let's solve the problem. Because we are already decided that we have to look for the LCM of these 3 numbers, the fact that we have to look for the shortest time where these 3 numbers will meet. So, in order to get the LCM of 8, 16, and 24, we will also have to use the prime factorization. The prime factorization of 8 is 2 times 2 times 2 using the continuous division. For 16, we will also use the continuous division, and 16 is divisible by 2, which is equal to 8. 8 is also divisible by 2, which is equal to 4. 4 is also divisible by 2, which is equal to 2. And 2 is also divisible by 2, which is equal to 1. If you already reach 1, here's the prime factorization of 16. 2 times 2 times 2 times 2. And finally, for number 24, 24 is divisible by 2, so that is equal to 12. 12 is divisible by 2, so that is equal to 6. 6 is divisible by 2, so that is equal to 3. And 3 is divisible by 3, which is equal to 1 now. So the prime factorization of 24 is 2 times 2 times 2 times 3. To remind you all that in getting the prime factorization of any numbers, all you have to do is use the factor tree or continuous division. Either of these will arrive at the same prime factorization. After we already have the prime factorization of these numbers 8, 16, and 24, the next thing that we have to do is to get their common factors. So their common factors here, or the CF, which stands for common factors, are the following. 2, another 2, another 2. So they are common because these numbers can be found or here as factor of 8, 16, and 24. This time, because we are not looking for the greatest common factor, if you will try to multiply 2 times 2 times 2, which is equal to 8, that's the GCF of these 3 numbers. But we are looking for the shortest time where all these 3 meet together. So we are not looking for the factor. We are looking for the smallest time where the three will meet together. That means we are looking for the smallest or least, so we are looking for the least common multiple. And to get the least common multiple of 8, 16, and 24, all we have to do is to add the rest of the factors which are not common. So we have another additional of 2 here and additional factor of 3 here. This completes now the factors common and non-common, which is the least common multiple of these 3 numbers. All you have to do to look for the least common multiple, you multiply the factors here. So 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24, 24 times 2 is 48. Therefore, the smallest number where 8, 16, and 24 will meet is 48. So in our problem a while ago, you are looking for the smallest or the least, the shortest time that all this will meet, all this van will meet. So the correct answer for that is after 48 minutes. So that's how we solve our problem about GCF and LCM. You really need to understand which is the fitting solution to the problem. Will it be GCF or LCM? So read and understand the problem first. Your next activity is reflected in page number 7 of your module number 6, first quarter. That is what's more. Here in what's more, you are asked to get the common factors of these 2 numbers, these 3 numbers, and these 3 numbers. I will give you item number 1, number 2, and number 3 as examples. Then after this one, the rest of the activity, you will do it by yourself. Kindly reflect or kindly channel your attention on page number 7 of your module number 6. Common factors. After you already have the common factors of these numbers, then you have to look for their GCF or the greatest common factor. This is the biggest factor out of the factors of the given numbers. Of course, the next part is first common multiple of these numbers. When we say first common multiples, this is also the least common multiple. The fact that this is the first, therefore this is the smallest number where these 2 numbers meet. So we are looking for the least common multiple or first common multiple. Let us start your activity. To start, let us first get the common factors of 36 and 48. Both numbers are divisible by 1 because 1 is always a factor of any number. So both numbers are also even, so divisible by 2, also divisible by 3. These 2 numbers are also divisible by 4, even by 6, and by 12. So these are the common factors of 36 and 48. After that one, look for their GCF. And the GCF is equal to, of course, that's 12. How about let's try 12, 16, and 30. Let's look for their common factor first. Of course, they are divisible by, the 3 numbers are divisible by 1 and by 2. No more. So therefore, their greatest common factor is equal to 2. For item number 3, these 3 numbers are divisible by 1, of course. And of course, they are all even numbers, so they are also divisible by 2. And they are also divisible by 3. These 3 numbers are also divisible by 4. I think they are all divisible by 6. And also by 12. No more. So their greatest common factor is 12. You could use your pair of factors in order to get the common factors of these numbers. In order for us to complete the table, the next thing that we have to do is to look for the first common multiple of 36 and 48. However, I find it impractical for us to look for the multiples of 36 at the same time to look for the multiples of 48, because these two numbers are big enough for us to skip count by 36 and by 48. Or if you wish, you could multiply 36 by 1, by 2, by 3, by 4, by 5, and also 48, you multiply it by 1, by 2, by 3, by 4, by 5, by 6, by 7, until you have a common multiple of both 36 and 48. So I think because we are only asked to look for their first common multiple, I think it is just okay to use the continuous division or prime factorization in looking for their LCM, which is also the first common multiple. So for 36 and 48, both number are divisible by 2, so that will give us 18, and this is equal to 24. Next, both number are also divisible by 2, so you could have here 9, and this is equal to 12. Both number are divisible by 3, so this is equal to 3, and this is equal to 4. There is no more common factor to the both of them, so this is now your LCM. Okay, so you multiply 2 times 2 times 3 times 3 times 4. So 4 times 3 is equal to 12. 12 times 3, that's 36. 36 times 2 is 72. 72 times 2, it's 144. So that is the first common multiple of 36 and 48, which is also the least common multiple, because that's the first multiple, therefore also that's also the smallest multiple where these two numbers 36 and 48 will meet. Your next activity is still reflected on page number 7 of your module number 6 for first quarter. And here in what's more letter B, you are asked to identify if the statement is true or false. So if it is true, all you have to do is write T. However, if the statement is false, you have to change the underlined words or numbers. Number 1, the underlined here is LCM. Number 2 is 180. Number 3 is 2 times 3 times 5. Number 4, that's 120, and number 5, that's 140. So this is a modified true or false. Write T if the statement is correct or true, and if it is false or not correct, all you have to do is to change the underlined words or number. I will give you time to answer this activity, so pause this video and try it by yourself. Let us now proceed to what I have learned activity on page number 8 of your module number 6. So get ready. I want you to get your notebook now and number it from 1 up to 4. You will have to choose your answer from here, letter A to letter F. I will read to you the problem or the question, then you will have to choose from the choices here and write that on your notebook. Then later I will reveal to you the answers. Let us now proceed to question number 1 if you are ready. If you are not ready yet, pause this video and get your notebook. Question number 1. These are the factors of 2 or more numbers which are the same in all of the numbers in a set. Again, these are the factors of 2 or more numbers which are the same in all of the numbers in a set. Question number 2. It is simply the smallest of the common multiples. It is simply the smallest of the common multiples. Question number 3. This is done to determine the LCM of 2 to 4 numbers using continuous division for all numbers in a set. Again, this is done to determine the LCM of 2 to 4 numbers using continuous division for all numbers in a set. Question number 4. The greatest factor that 2 or more numbers share. The greatest factor that 2 or more numbers share. Let us now see what are the answers in our activity, what I have learned. For item number 1, the question is, these are the factors of 2 or more numbers which are the same in all of the numbers in the set, and the correct answer is common factor, letter B. Check your own work. For question number 2, it is simply the smallest of the common multiples. Of course, the first common multiple or the smallest multiple is what we call the LCM. That's letter C. For item number 3, this is done to determine the LCM of 2 to 4 numbers using continuous division for all the numbers in the set. All you have to do is to multiply the common prime divisors. So that's letter F. And finally, for item number 4, the greatest factor that 2 or more numbers share, that is what we call the GCF, letter A. Let us now proceed to our next activity, which is what I can do. For activity 1, all you have to do is to find for the factors of 60 and arrange them in increasing order in order for us to determine what's the value of A, B, C, D, E up to J. Remember that all of these are factors of 60. List down the factors of 60 and arrange them in increasing order. Here's 1. What's the value of A, B, C up to F? And here's the last factor, which is 60. Now, look for the factors of 60. For letter B, all you have to do is list all the factors of 225. Pause this video and answer your activity. And now, let us see what are the answers for activity 1, letter A and B. For activity number 1, letter A, the factors of 60 are the following. 60 is equal to 1 times 60. That is also divisible by 2, so 2 times 30. At the same time, that is also divisible by 3, that's 3 times 20. Also divisible by 4, that's 4 times 15. Also divisible by 5, that is equal to 5 times 12. Also divisible by 6, that is 6 times 10. Not by 7, not by 8, not by 9, and 10 is already there. So it simply means this is now complete. So 1 is already listed there, and 60 is already listed here. So the value of A is 2, the value of B is 3, the value of C is 4, D is 5, E is 6, of course F is 10, G is 12, H is 15, I is 20, and of course J is 30. So those are the values of these letters. Now let's proceed to letter B. All the factors of 225. So 225 is equal to 1 times 225. Of course, this is not divisible by 2, but by 3, I think. That is divisible by 3. So because 5 plus 2 plus 2, that is equal to 9. So let's divide 225 by 3. The answer is 7, 21, 1, 5, bring down 5. So 15 divided by 3 is equal to 5. 5 times 3, that is equal to 15, 0. So that is equal to 3 times 75. Now that's not divisible by 4, but by 5 for sure. So 225 divided by 5, that is equal to sorry, that is equal to 4, that's 20, then bring down 5, that's equal to 5, that's 25, 0. So that is 5 times 45. This one, I think, is not divisible by 6, by 7, by 8, by 9 for sure, because 5 plus 2 plus 2 is equal to 9. So 225 divided by 9, that is equal to 2, that's 18, subtract 22 and 8, that is equal to 4, 5, so that is 5, 45, that's 0. So the correct answer is, or the pair of factor is equal to 9 times 25. Of course, not by 11, not by 12, 13, 14, and 15. I think this is divisible by 15 because 225 divided by 15, that is equal to 1, 15, that is equal to, subtract that, it's 75, that's 5, that's 75, that's 0. So therefore, that is 15 times 15. So if you are asked, this is already now complete because 15 is here and also here. So therefore, to give you the list of the factors of 225, the correct answers are 1, 3, 5, 9, 15, 25, 45, 75, and 225. This is the answer for letter B. Let us now proceed to our last activity before we will have our assessment. So this time I want you to take out your math notebook and number it from 1 up to 10. For our last activity, which is on page number 9 of your module, activity number 2, you are asked here to mark, check if the statement is true, and X if the statement is false. So get ready, for I will read to you the situation or the problem, then you just write check or X. If I'm too fast, you may pause the video and answer, then just play it if you are ready for the next problem or situation. So get ready. We will start now our activity 2 for what I can do. Question number 1. In finding the GCF of two numbers, the common factors are to be listed down. Again, in finding the GCF of two numbers, the common factors are to be listed down. Question number 2. The LCM of 12 and 8 and 20 is 310. Again, the LCM of 12, 8, and 20 is 310. You may pause this video for you to solve, then answer, then play it again. Item number 3. The number 16, 60, and 24 has an LCM of 240. The number 16, 60, and 24 has an LCM of 240. Question number 4. The LCM of 18, 20, and 36 is 60. The LCM of 18, 24, and 36 is 60. Question number 5. In finding the GCF of two numbers, after the prime factors are listed, it has to be divided. In finding the GCF of two numbers, after the prime factors are listed, it has to be divided. Question number 6. The GCF of 20 and 28 is 2. The GCF of 20 and 28 is 2. Question number 7. GCF is the biggest number that will divide both the given numbers. Number 7. GCF is the biggest number that will divide both the given numbers. Question number 8. The GCF of 30 and 28 is 6. The GCF of 30 and 24, is 6. The GCF of 30 and 24 is 6. Question number 9. To find GCF of given numbers may be done by prime factor 3. Again, to find GCF of given numbers may be done by prime factor 3. And finally, number 10, there is no GCF if there are no common factors of the given numbers. There is no GCF if there are no common factors of the given numbers. Let us now answer your last activity. And now let us check if how many points will you get from this what I can do activity number 2. So, for item number 1, in finding the GCF of two numbers, the common factors are to be listed down. That's true. One check for that if your answer is check. For number 2, the LCM of 12, 8, and 20 is 310. Let's try to check and verify that one. 12, 8, and 20. So, 3 numbers can be divided by 2. So, the answer is 12 divided by 2 is 6. 8 divided by 2 is 4. 20 divided by 4 is 10. By 2, is 10. Next, all of them can be divided by 2. So, that is 3. Then that is 2. Then that is 5. Next, there is no more 2 or more numbers that could be divided by another number, so you stop there. This is already their LCM. And their LCM is, this is 10. Next, 3 times 2, that is 6. 6 times 2, that is 12. So 10 times 12 is 120. In the problem, that's 310, that's X. So if your answer is X, another point for you. For item number 3, the number 16, 60, and 24 has the LCM of 240. Let's try it. Let's try 16, 60, and 24. LCM. Let's look for their LCM. 3 numbers can be divided by 2, so that is 8, 30, and 12. Next, 8, 30, and 12 can be divided by 2, so the answer is 4, 15, and 6. Next, these 2 numbers here, 4 and 6, can be divided by 2. If there are 2 or more numbers that can be divided by another prime number or another number, then you should continue on dividing. So 4 divided by 2, that is equal to 2. Then 6 divided by 2, the answer is 3. Just bring down 15. If you notice, 15 and 3 can be divided by 3 again. So that is 15 divided by 3, that is 5. 3 divided by 3 is 1. And of course, just bring down 2. Now, here, there is no more 2 or more numbers that can be divided by another number, so you stop there. So this is already the LCM. So 5 times 2, that is equal to 10. 3 times 2, that is 6. 6 times 2 is 12. 12 times 2, that is 24. So 24 times 10, that is equal to 240. In our problem, it says here that their LCM is 240, so that's check. And next one is the LCM of 18, 24, and 36 is 60. That's not true, or that's not correct. For number 5, in finding the GCF of the 2 numbers after the prime factors are listed, then you have to divide them. So that's X. You should multiply rather than, or you should multiply and not divide. For number 6, the GCF of 20 and 48 is 2. I think there is still a bigger number that could divide both 20 and 28. That's not 2, but rather 4. So the correct answer is X. For number 7, the GCF or GCF is the biggest number that will divide both the given numbers. That's check. Okay? For number 9, for number 7, for number 8, the GCF of 30 and 24 is 6. I think that's check because that's the biggest number that could divide both 30 and 24. For number 9, the GCF of the given numbers may be done by prime factor 3. That's check. We could use prime factor 3 method to get the prime factorization. Then you can get also their GCF. For number 10, there is no GCF if there are no common factors of the given number. Always remember, as I remind you again, that if there's no common factor, of course, remember that all the numbers are divisible by 1, or all the numbers has a factor of 1. Therefore, if there's no common factor to all the numbers, their GCF, we could not say that there's no GCF. There is a GCF, but the GCF is 1. Therefore, this statement is wrong. So with that completes our activity for module number 6. The next thing that you have to do is to open your module on page number 10 and answer your assessment. This one will be answered in a one whole sheet of pad paper to be submitted to me on the time that we will retrieve your module. So that would be all for our module number 6. Thank you so much for joining me, and I hope this one is very meaningful for you.